Okay, so example 3 is a very typical question that will that will appear in the public exam. So listen carefully. So let's first look at the question. State the color change at the endpoint. Endpoint, that means when the color of the indicator changes sharply, then that will be the endpoint. It is called endpoint because when the color of the indicator changes sharply, we will end the titration. Right? So that's why usually the question asks you to identify the endpoint so that you know the color change and end the titration at the appropriate time. So usually you need to comprehend what happens the experiment is doing. So now we have the buvette and the conical flask. We know that the sodium carbonate solution is put into the conical flask according to the question. So that's why the buvette will be H2SO4. So although we do not know the pH of the sodium carbonate, that is impossible to remember that. But we know that at least it is not strongly acidic. So if we know that's truth, then we know that when methyl orange is put into a solution that is not strongly acidic, usually that will be yellow color. Okay, so yellow color. Okay, we have the yellow color. So when it reacts with the sulfuric acid, then it will bit by bit turn it into acidic. So at last, it must pass through a color which changes to orange. That will be the endpoint color, yellow to orange. Okay. Although when that is in practical experiment, you will overshoot a little bit. Usually you will have the red color instead of orange color. That will be a very hard work for you to attain an orange color. Right? But theoretically, we will say that the endpoint color change is yellow to orange. So next, we need to calculate a reasonable average volume of sulfuric acid used for each titration. So reasonable, that means we will not take all data to calculate the average volume. Well, because for the trial, you can figure out that the trial data is obviously the outlier between among the four data. Okay, the outlier. Right? That is very obvious because in the trial, we do not know when the titrations will end yet. So usually you will overshoot. That means usually you will have more than enough volume as your result. So that's why if you start at the next titration, you can take 26.6 cm³ as the reference. Then you can find out the endpoint more accurately. For the third trial and the fourth trial would also have the same case. So usually we will neglect the outlier when we are calculating the average. So that is what we call the reasonable average. So remember that we need to divide the whole data by 3, but not taking the average for the 4 data. So at last you have 25.80 cm³. Remember you have 2 decimal places. Right, that is because your data taken is 2 decimal places. So that's why for the average you should have also correct it to the 2 decimal places. Then for the calculation it's just normal. You write down the equation first, write down the data you have, and then find out the number of moles of given data. This time is sodium carbonate. You have the full set data to calculate the number of moles. Then we have found out 1.3175 times 10 to the power negative 3 moles. Then write down the mole ratio between the given data and the required data. This time we want to find out the molarity of sulfuric acid. Then the number of moles of sulfuric acid will be also equal to the number of moles of sodium carbonate. Then from the formula, molarity equals to the number of moles divided by the volume. The number of moles is calculated just now. Then the volume is the reasonable average we calculated in B. Then we found out the molarity is 0.0511 m, corrected to 3 significant figures.